Hi guys, I'm Santosh Sharma. I welcome you to my YouTube channel and also my website techguru4u.com. So today I'm going to make the video on Fortigate Packet Flow, and if you will search, it is also called life of a packet. Okay, and in that I'll explain you that when the packet is received in ingress interface and it is delivered to the egress interface, between that there are a lot of processes happens in the firewall, like firewall has to check routing policy, UTM profile. So how firewall takes decision on these things. Okay, and what another thing that I would like to discuss with you is when you search, it is life of a packet, but as per my thinking, it's not life of a packet, it's life of packets, or you can say life of a session. Why that so? Because when the firewall receive SYN packet, firewall perform actions which are different. When firewall receives SYN-ACK, those on the SYN-ACK firewall perform different actions which were not in the SYN-ACK, or which are less than which was performed in the SYN packet. Okay, sorry. And when ACK goes in, that firewall performs different action, and then your HTTP GET request comes, then response comes, and in that also different actions are performed, because now it becomes application layer packet. If you have applied the UTM feature, that will be applied. And if it is HTTPS traffic, then S makes it secure, makes it encrypted, and in that obviously firewall need to decrypt if you have applied the decryption. So in that it will apply different actions. Okay, so I think it's not life of a packet, it's life of packets, or in one line we can say life of a session. How a session is handled means in that session how different packets are handled by the firewall. Okay, so let's move into my screen. I would like to request you, if you like this video, please press on the like button. If you dislike, please dislike the video if you don't like it, and also give a comment why don't you like, so I would like to improve in that. Okay, and I also have my website techguru4u.com. If you would like to join a paid course, then you can see what are the content that we are covering, and that's really very detailed. It's like high level you will always get in YouTube. Okay, but if you want to do a deep dive on every topic, policy, NATing, UTM, then you can enroll the course. Okay, let's continue.
So this is what we need to discuss today, Fortigate Packet Flow. And Fortigate Packet Flow consists of 4 stages. One is ingress check, and the last one is egress check. So these are easy to remember. And in between that, you have stateful inspection, and then you have UTM inspection. Okay, so it might be looking like very easy. It's very easy, like we can remember that, but there are further sub steps in these steps. Okay, in these main steps. So let's check what they are. So in the ingress, these are the steps in all the 4 stages. I will explain you one by one. So this packet flow I have taken directly from FortiGate's site, and as per this packet flow, this is how packet comes inside to one of the interface, which is called ingress interface. If your packet is received from LAN, then it is called as ingress interface. If your packet is received from the WAN, then WAN is called as the ingress interface. It means wherever the first packet is received, that is called ingress interface. Okay, so you have packet is received in the interface, then it does further processing. Okay, and these all. So this might be looking like more detailed. What I have done, I have taken reference from this, and I have made packet flow myself for FortiGate, and this is how it looks like. So I have what I have done. I have taken the packet flow of Palo Alto, and I tried their way of explaining the packet flow, and accordingly, I have put the things in that. So it will become very easy for you. Like if you will compare, if you already know packet flow of Palo Alto, then it will be very easy for you to understand. Okay, so let's understand from this. Okay, ingress process. When packet will come to your any of the interface, maybe it's a LAN interface, then what happens? It will extract some information that is layer 2, layer 3, and layer 4 information. Okay, and it also have the information on which interface that packet has been received. Okay, so when you will check in the CLI, so this is how it will look like. It will give ID to that, and this is the ID number. Okay, so print packet detail line VD LAN. So this is a virtual domain LAN and receive the packet. So it is saying it has received a packet proto 6. It's a TCP. Okay, so this is the source. This is source port. This is destination. This is destination port from VLAN 1001, and the packet is SYN packet. Okay, so it is also having sequence number. It doesn't have acknowledgement because yet acknowledgement has not come back if you already know three-way handshake. Okay, so it has the window size. So this all information is received in the ingress interface. Okay, it does some of the things like it checks the TCP IP stack. If you have configured the DOS policy, then it will check the DOS policy. If it will also check the IP integrity, and if IP integrity is not good, it will discard the packet. Okay, if your packet is IPsec VPN packet, then obviously if it is a VPN, it needs to decrypt the packet. So it will again go back here. Why it will again go back here? Because it needs the original IP address. Your policies are made for original IP addresses, okay, not for the public IP. That's why it need to decrypt and see what is inside, what are the actual IP addresses. Okay, so it will again come back like this way. Okay, when your packet will reach here, it will check the session table. Okay, and it will check find an existing session. Okay, and it will try to find existing session. If it will not find an existing session, how it will come to know if there is existing session or not? For this, it should be matched with the session table. Okay, so when it checked in the session table and it said, okay, I already have session, I found an existing session, and this is original direction, and it will send the packet to the fast path. Now here we have two paths, slow path and fast path. Okay, so in Fortigate, when we talk about fast path, so there are two fast paths in Fortigate. Fortigate has mentioned only one, but I will explain you the second one also. Okay, so when it has checked there is no packet, let's consider it's a first packet. Okay, it's not existing packet. So if it is not existing packet, so session will not be found, and it will go here and say, okay, I don't find the session, please allocate a new session. So this is how you will see in the CLI. It will assign some ID number, trace ID number, and init IP session common. This is okay. So what is the message? Allocate a new session, and this is the session ID. Okay, so now your packet will enter in the slow path. Why we say slow path? Because these are the things that need to be checked. It need to be checked destination NAT, if there is a DNAT or not, if there is a routing or not, if there is a policy, if there is a source NAT. So these all things need to be checked. Okay, so this wastes some of the time of firewall because it's a first packet, so it's a mandatory. But once these all things are checked and session is installed in the session table, these checks not need to be checked again. So that is the benefit of session table, and that's why this is called slow path and this is called fast path, because remaining packets will be checked on the basis of session table. Okay, if we discuss more about slow path, destination NAT, it is not mandatory like destination NAT should be there. Maybe destination NAT is not configured and it is not required, like your traffic is going from LAN to DMZ. In that case, destination NAT is not required. LAN you can configure, but it is not mandatory. Okay, from LAN to WAN, destination NAT is not required. Okay, but from WAN to DMZ, destination NAT is required. Okay, so this is how it will check the DNAT. Okay, so let me also take you here. So where we are right now, we have discussed session tracking. Okay, and we have discussed session tracking before destination NAT and before routing. But if you will see, the packet flow which has been given by Fortigate, they are saying destination NAT will happen, routing will happen, then stateful inspection will start, like policy lookup will happen, and after policy lookup, session tracking will happen. This really doesn't make any sense to me. This is illogical. If it will again and again check the destination NAT, routing, policy, and then it will check the session tracking, then what is the benefit of session table? Like, it's wasting time. Then I also captured packets and in CLI, and I came to know, okay, this is really wrong. That's not defined properly. Okay. There is another thing which is not defined by Fortigate. Before I forget to explain you, is they have not defined anywhere where SSL decryption is happening. Okay. So I will explain that in today's video. Okay. So this is the packet flow, destination NAT. Destination NAT, if it is not available, then it will go to the next step. So let me show you another slide for the CLI, how it looks like. I think this one. Okay, here you see, I will just maximize it. Okay, this is first SYN packet. Okay, how I come to know this is SYN packet? This is like I have taken a packet capture, and this is the flag shown here. S is this flag for SYN packet. Okay, and acknowledgement is 0, so it means it's the first packet. Okay, so the same information, like packet is received and it is proto 6, means it is TCP packet. This is source, this is destination. Okay, so as per our packet flow, what happens if it is not part of existing session? It will allocate a new session. So this new session is allocated. After allocating a new session, the first thing is destination NAT. It will check the destination NAT and see incoming port 2, outgoing, there is nothing outgoing, and there is another message. What this message say? No match. If you see here, read no match. No match is found for the destination NAT. This iprobe DNet check. So this complete line is for DNet, and it said that no match is found, but ACT is equal to accept. Action is accept. So it has passed to the next step. Okay. So the next step, as per our packet flow, maybe you need to remember it because I will keep on shifting the screen. The next step is routing. Okay. So what happens in the routing? Let's go back here. In the routing, you will see this kind of message. This one, 112, function VP if route input common. Message is find a route. So like Fortigate is commanding find a route for this destination. Routing is always found for destination, because if you have static routing or dynamic routing. If you have policy based routing, then that is a different concept. That's also source based. Policy based is a source based routing. Okay, find a route. So it will find a route, and it is found, okay, the gateway should be this one. So this is like I have done it in my lab. So this is my WAN IP address, and it said that, okay, it is going from port number 5 outside. Okay, so it has found the routing. Now let's go back here. There is a one question, why routing is before policy? Routing is before policy because it saves CPU of firewall. Policies can be 5,000, 10,000 in a big environment, and routing can be maybe 50, okay, or maybe 20, 50, or 100. Means routing will always be less, okay, but policy will always be more. So firewall has to check policies from top to bottom. So it will utilize a lot of mind. And after checking the policy, if there is no route, it has to drop the packet because route is required. Okay, so it's good to check route first. Okay, it will check route and it will drop itself there. It will not process further. So it will save your utilization of the firewall. So this is by design. That is why it is before the policy. Okay. Now, what is the next message? It has found the routing. Port 2 is incoming and port 5 is outgoing. You see here out. Okay, so now let's go to the next message. iprobe check 1 policy. Okay, message checked. It has checked the policy and policy is port policy 3. Okay, read match action is accept. If it would be dropped, it will drop the packet here itself. Okay, so now let's go here. So we have seen that after routing, it has commanded to check the policy, and policy message says that allowed by policy, whatever policy is allowing it. And after that, if you don't have policy, it will drop. If you don't have routing, it will drop. But in case of destination netting, if it is not available, it will go to the next. That's why I have not dropped it. Source netting is also not mandatory. Like if your traffic is going from LAN to WAN, in that case, obviously you don't need source netting. Okay, you can configure, but it's not mandatory. So your packet should not be dropped if there is no source netting. Okay, so now it will check the source netting. So this is how it checks. You will see this thing in the CLI. Find SNet IP. So this is the IP from IP pool. Okay, and it assigns one port number to it. So this is IP of my outgoing interface because I have selected SNet to be from outgoing interface. So it has checked, okay, find in SNet, and it has already found from the IP pool. Okay, so now there are two things. Here, Fortigate has allocated a new session, but when a session is allocated, it doesn't mean it will show in the session table. Session table will be having sessions after crossing these all, and after that, session will be installed in the session table. Okay, so it's not like that if a session is created, you can find it in a session table. Okay, if the session is dropped, it will not be in the session table, but there is a command where you can configure that your dropped packet should also be in the session table. What is the benefit of that? Like the benefit is that if your dropped packet are also in the session table, then your firewall doesn't need to do the checking again for subsequent packets. It will match from the session table and it will say, okay, it is dropped. Here itself, it will say, okay, it's dropped, just it will discard the packet. So it will not go here. If you will add dropped sessions also in the session table. Okay, so you need to mention that command. That is a one-line command. You can mention that. Okay. Okay. Now this thing is done, and let me check if I missed something. Okay, so this thing, when your session is installed, how does your session looks like in the session table? So this is how your session looks like in the session table. This is Proto 6 and Proto state 01. There are a lot of proto states. For troubleshooting, you have no need to remember the states, okay? Because since in ACK, it's very quick process and you will always see 01. 01 is when your connection is established, okay? Then there is may dirty. May dirty flag is when firewall has allowed, like there is already policy, layer 3, layer 4 policy is already there, then the state is mentioned as a may dirty. Okay, there is another thing, there is another state dirty. When that dirty state will come, like if you have done any changes in the firewall policy or routing, and that ongoing sessions are part of that existing policy and sessions. Okay, I will explain it again. Like suppose I have configured LAN to WAN policy, and one user is using something. Okay, so his session is already in the session table, but I have done some changes in the policy. Maybe I have changed the UTM profile, something I have done. So may dirty flag will change to the dirty. So what it tells? It tells to the firewall that now you need to do the inspection again. Check if there is a policy, check all those things are there. Okay, so that is the purpose. So it's dirty flag is for re-evaluation. Okay, and after dirty, if there is a policy, then it will again put the state as a may dirty. Okay, so this is may dirty and dirty stages. So after may dirty, there is NPU, network processing unit. Network processing unit will handle the packet, and that is also called fast path. You can say it as a second fast path in Fortigate. First fast path is which avoids DNet, your source net, okay, DNet routing policy source net. Okay, so it avoids that. Okay, and that one is the second fast path which allows you to use the network processing unit. What is NPU? I will explain you. Okay. What else you see in the session table? You see pre and post hook. Okay, so pre-hook is this one is a pre-hook, and this one is a post-hook. Okay, what else you see here? You also see the routing. Okay, so this origin, this is for routing. Okay, gateway, this is this. Okay, it says, okay, this is the routing, this is the initial packet, and this is the second packet. Okay, it's a lot of information in the session also, like when you will see SNET. If there is SNET is enabled, how the packet will look like. If DNET is enabled, how the packet will look like in the session table. Okay, but that's not today's discussion. I want to tell you that in the session table, you have this information. You have the routing, you have netting, denetting information, you have policy ID. So in session, you have all the information of slow path. All the information of slow path is in the session table. That is the reason session tracking should not be after policy, which is mentioned in the packet flow of the Fortigate. Okay, so let's be here. Okay, so now session is installed in the session table. Now your session looks like this. Okay, when the next packet will come, it will check in the session table, and this you will see this message: find an existing session, original direction. Okay. Okay, so I want to show you this one. Okay, as I told you initially, like it's not a life of a packet, it's life of packets, or it's life of session. Okay, the session which has been assigned. So because SYN packet is treated differently, SYNAC is having different packet flow. Now SYNAC, what will happen with the SYNAC? SYNAC will not go through all the above things. Okay, so this is your second message. What you see here, this was a part of first SYN request. Okay, how I come to know about that is you see here 112. So it's also here 112. So this is first packet, and in that first packet, I forgot to show you like how it find these SNAT. It just command find SNAT. So this is it found from the IP pool, and at the last it just mapped. Okay, this IP will be SNAT to this IP. Okay, all right. So this is your SYNAC. Okay, this is SYNAC packet, and how I come to know this is SYNAC. You see here flag is S, and if flag is S dot, then it is SYNAC packet. Second thing is it was 112. Now it became 113. Okay, the ID becomes 113 if you will see. This ID will remain always same. Okay, 20085. I think this is a model specific or version specific, because I have seen in many models this ID remains same. Okay, so received a packet. Now the packet is received, uh, like the initial packet went from LAN to WAN. Okay, now packet is coming back from the WAN. So this is beauty of stateful firewall. Like it already have a state, it already have a session. Okay, received a packet. This is the packet from port number 5, SYNAC, sequence acknowledgement, this one. Okay, message find an existing session. Okay, so it has tried to find an existing session, and you will see here 0 410.087B4. 410.087B4. So it has found an existing session. Okay, so this is DNAT, this one, this one. So this DNAT is part of the session which was created earlier. If you will see the session table, in that session table, when the SYN packet goes, it automatically create DNAT. Even though DNAT is not required for LAN to WAN, but it's a reply direction. That's why it's called a DNAT. When the reply will come back, then to whom that reply should go. So that is already in the session table. Okay, so from the session table, these things are checked. Okay, find the route. Okay, see these all things are checked, and packet is delivered outside. Okay. Okay, I hope this thing is clear. So let's go here. One question for you before we proceed. You can pause the video. You can tell me what are the steps in the slow path. Just stop the video and type your question answer in the comment. Okay, and also comment why routing is before policy. Okay. Okay. So now your packet comes in the fast path. Before explaining this packet flow, I will take you to the Fortigate's packet flow. In Fortigate's packet flow, so we have passed this thing. Okay, these all things has been passed, and now you are in the UTM. Okay, so we are in the UTM. So session tracking, traffic shaping, user authentication, SSL VPN management, traffic session helper. There is nowhere it is mentioned as a decryption. Okay, if you have enabled the decryption, then when it will happen. So this should be mentioned somewhere. I have also not mentioned it here. I need to modify this, but I will explain you now. Okay, let me take a pen. So now, question to you. When Fortigate Firewall will identify the application? When Fortigate Firewall will identify the web filtering, means perform the web filtering. Okay, so only based upon these things. And when SSL handshake will happen, sorry, SSL decryption will happen. Okay, so I already answered. When SSL handshake will start, during that time, your decryption should happen, because it will just encrypt the packet and firewall would not be able to see the packet. So what happened? This is your client and this is your server on the cloud, and your client is sending packet here. You have enabled the decryption. Okay, so you have installed self-signed certificate here, or you have taken a certificate from CA. Okay, so your communication is from here to here. This is thinking that he is going to the Google, but actually he is not going to the Google. What is happening? Your firewall is sending, this is sending send packet to the firewall. Firewall is sending send packet to this one, server, Google maybe. Okay, and firewall is getting reply back, and firewall is sending final acknowledgement. So firewall is initiating connection on its behalf for client, and then firewall is replying back to the client also. Okay, so what is happening when the packet is coming here? Firewall is just opening a packet. Okay, because firewall have the certificate. Certificate is a different thing. Maybe you may get confused in that, so avoid that. Just try to understand what I'm saying. Okay, so firewall will again encrypt the packet with its own certificate and send to the client. So this is how it works. So if I talk about when firewall will find application and when firewall will do the web filtering. Okay, so let's talk about web filtering first. Web filtering, when web filtering is applied, when your HTTP GET request will go and your response will come back. In the response, your web filtering is applied. Okay, but if you have not enabled the SSL deep inspection, in that case, will your web filtering not be applied? No, that your web filtering will be applied, because you have client hello. In client hello, you have SNI. In SNI value, it goes a domain name. Okay, domain name goes in that. Okay, so there is alternative for that, but other things doesn't work properly if you have not applied decryption. Okay, so suppose we have applied the decryption, and we know that HTTP GET request will go and response will come back. Okay, so response came back, and firewall, when the response came back, firewall also got rating. Rating is live queries. Firewall got the rating for that URL, if it is under which category, information category or under malicious category, and then it will check your URL filtering profile if informational is allowed or blocked, and from there it will apply the action. Okay, so for this, for reply packet, your decryption should happen before. So your decryption will happen first, SSL. I will remove these all. So here, when packet is sent here for the fast path, your SSL decryption will happen first. Okay, your SSL decryption happens. And now question is that when application control happens, okay, so application control is where your application is identified, whether it is youtube.com or it is a facebook.com, okay, or inside a Facebook it is a FB chat. I think that's a more good example. What it is, if these are also in a URL, so URL will be identified by the web filtering, and it will check, web filtering will check obviously what is inside that. Then after checking web filtering, why it will check the application control. Okay, so application control is always checked first. There is another explanation for that. Like application control is, I think, just name, but it is handled by the IPS engine. When any packet is received, maybe your HTTP GET request is received, your three-way handshake need to be processed for application control to come in the picture. Okay, so your three-way handshake happened, and then now your HTTP GET request came to the firewall. So there is amount of data, almost 2000 bytes of data has already been exchanged, and now the packet came to the firewall. Firewall application control, what happens? It gives the packet to the IPS engine. IPS engine will check in its database, okay, because IPS in your application can work on different protocol, different port numbers. Okay, so IPS is the only signature which can identify application whether it is working on a different port number. Like your peer-to-peer application works on a different port number. So that is the reason IPS then application, because application is dependent on IPS, and IPS is the only UTM feature which gets triggered on SYN packet. Okay, for your other UTM features to get triggered, it need to complete three-way handshake. Now you're understanding, like your packet flow for every packet is different. Okay, now you have HTTP GET request, your IPS was already triggered because it also comes first in the picture. And the second thing is your IPS is always flow based. Even if you configure your firewall to be proxy based, your IPS is always working as a flow based. Okay, so your IPS has checked which application it is, and then it has forwarded the application to the web filtering. And then web filtering will check your URL, your domain name, and it will do some of the checks. In that also there is a static URL flow of web filtering. Static URL will be checked first, then it will check the category, okay, in the web filtering. So it has checked all these, and if it is allowed, it will send to further. If we talk about DLP, if we talk about antivirus, let's talk about antivirus. So antivirus is why after web filtering, because once you need to open any website, and then you will download something from there, and in that file there will be something malicious packet, and that malicious packet is however it is configured, it will be blocked. There is also a limit, like 10 MB is default limit, and if your file size exceeded from 10 MB, then it will not be checked by the firewall. If I have to give you an example of that, if you have ever downloaded anything from the Chrome, and if it increases from a certain size, it will say, okay, cannot scan it. You will get here some notification, you want to keep it or you want to discard it. Okay, so this is how it happens. Okay, second thing, when I say you IPS gets triggered in this SYN packet, what does it mean? Like if you know DDoS, how DDoS is handled, your IPS handles the DDoS. So DDoS works on the basis of SYN packet only. Like attacker is sending a lot of SYN requests, okay, and firewall is sending back SYNAC. Obviously, the client is also sending to the firewall, and this attacker will never reply the final acknowledgement. So what happens? Firewall will be having a lot of open connections. Okay, so this is DDoS attack. What firewall does, I will take you to the slideshow. I'll just give you the highlight. Okay, so this is SSL DDoS, not SSL DDoS handling. Okay, this happens in the three-way handshake. SYN packet came is a spoofed SYNAC and ACK. What happens? Like firewall does the proxy. Firewall does the proxy, and firewall will not create a session until complete reply will not come back. Okay, like here ACK came, it is sending the packet to the client, but in this case firewall will not send packet to the server until client will not complete the three-way handshake. Okay, no SYN segment ever seen by listener. Packet will be dropped by the firewall. So these all things are handled by the IPS engine. Okay. Okay, so this is here SYN proxy and IPS subtype NO milli. Okay, so IPS is here. So this is your, for your SYN attack. So this information is taken. Maybe if you are interested, you can study that. But my purpose of saying was that IPS gets triggered first. Okay, even if it is a SYN packet. Okay, so let's go back again here. There is another thing. If we talk about fastpath, I told you that NP4 firewall, Fortigate firewall support ASIC, and that's really very beautiful thing. ASIC is hardware acceleration. It increases the speed of your firewall. Okay, how it increases the speed of your firewall? Let's again go back to the presentation and here. Okay, when we talk about ASIC, we have a three different kind of processor. One is CP, one is SP, one is NP. NP is network processor, which deals with network related tasks, routing, switching. These all things are handled by the NP. This is connected to the interface. SP is also connected to the interface. But what SP does? SP does IPS scan. Now you understood, like packet is received, SYN packet is received in the interface, and at the interface level, there should be some kind of engine which can check the packets. So IPS scan is happened by SP. There is another processor, which is CP, content processor. The task of content processor is it checks the antivirus, attack detection, encryption, decryption. So these all things are done by the content processor. When we say content, our content goes in the application layer, because when you download a file, that should be checked by antivirus. When you do encryption, decryption, that should be checked. Okay. So these all things are checked by the CP. Okay. So this is Fortigate's architecture. When I was telling you about the different processor, so this is how they are connected. Okay, so this is your interfaces. All the interfaces are connected to integrated switch fabric. This is very fast, so they can communicate with each other. Okay, and this is the flow. Just try to see this flow. The processors are connected to the CPU. Okay, NP6, CP8, and 9. Okay. So what happens here, I will explain you that. Like first packet is always handled by CPU. And if CPU checks that, okay, if there is a policy, what CPU will do? CPU will just copy the session key to NPU, any of the NPU, NP6 or NP1, NP6 0 or 1, wherever your interface is. Okay, so it says that check the policy, okay, offload the session. Now your session is offloaded and keys are copied to the NP6. Now your packet will go to the server. the subsequent packets are handled by NP6. They will never go to the CPU. So this will make the processing very fast. So that's why it is called fast path. Okay. For the best practice, always put your ingress and egress interfaces in the same NP6. Okay. So this example is, I think there is also, yeah, packet flow for that. So like NP6 has done its thing and keys are copied. Okay, three-way handshake happened. Now your encryption and decryption, or your CPU is your content processor, so content type of things happen. Antivirus will happen. Yeah, obviously encryption decryption is also part of that, so it will happen. So that will be handled by your CP8. So CPU will give the packet to CP8, but packet has to go from the CPU like this way, how I have explained it. So this is how internally they are connected. Even if CPU has to handle the first packet, NP6 will give that packet to the CPU. Like what happened, you have a manager and some new task came. Okay, so what you will say, you will give that task to your manager. You will tell to your manager, okay sir, I got this new task, what should be done? Your manager will check, okay, this is how he will do interpretation. He will check the policies and then he will say, okay, this task can be handled by you. Okay, so you can keep on handling this task. So this is how it works. So CPU will do the initial checks and then he will say, okay, you can handle it, and then the rest of the packet will be handled by NP6. For CP8, obviously the packet has to come through the CPU, and encryption, decryption, antivirus, all the content related tasks will be handled by CP8. There is another processor, SP, security processor, that does IPS, but I have not mentioned it here. So it should be here. It should be here. It is also connected to the your interface. Okay. One more thing in the session, like in this session, if you see post, 1 minute, I think I'm not able to show here. Okay, post. If you see post in SNAT, so post is means something happened after. Okay, so that's why it is a post here. Okay, so post means that source now will become this one. Okay, that's why post is here. If it is a LAN to DMZ traffic and you have not done any source NAT, DNAT, then it will be pre here. Okay, pre here, pre here. Okay, so that was one point. Okay, so packet flow is done, and at the last, your packet is delivered to the egress interface, where if it has done decryption in the starting for IPsec VPN, it will do the encryption, it will apply the traffic shaping, WAN optimization, and all those things will happen, and packet will be delivered to the outside interface. So this thing was important, this thing was important. So for troubleshooting, these things are really very important. Okay, there is a one scenario based example I will tell you. Like I have got issue, and that issue was related to one of the site was blocked by our antivirus, but it was not being blocked by our web filtering. Okay, so for this you should be aware how the flow works. Okay, if you know, okay, three-way handshake will happen first, and then HTTP GET request will come, and get reply of GET request will come. When the reply will come, at that time your web filtering will work. So you should be aware of that. But if you want to block three-way handshake also, so you need to apply DNS filtering. Okay, so maybe there are malicious sites and you want your Fortigate to not process even three-way handshake, so you can do that. Okay, so if you know the packet flow, then troubleshooting becomes very easy for you. Okay, so before closing, I would like to ask you a question. What is the difference between allocating a new session and installing a new session? Okay. The second question is when decryption happens in Fortigate. Okay. So answer that in the comment. I hope you like my video. If you do not like, please do dislike, and also do comment why don't you like. I would like to improve that, and maybe I will try to make another video for that. Okay, thank you. Bye.